All right, let's dive into some really cool research about how large language models learn. You know, those AI systems that can write like Shakespeare 1 minute and then code like a pro the next. Yeah, they're getting more and more powerful all the time. But figuring out exactly how they learn has been a bit of a mystery, like a black box you can't really see inside.
Yeah, that's a good way to put it.
Well, this research is trying to shine a light on what's happening under the hood. And trust me, it gets super fascinating.
What I think is so cool about this research is, well, it connects how LLMs learn with how we think. You know, you've probably heard of that fast versus slow thinking idea.
Oh, yeah. Like a
Well,
gut feeling versus really thinking something through carefully.
exactly. And that's what this research is looking at, whether LLMs show similar patterns when they're learning.
So how do they even study something like an LLM's thinking process? It's not like we can just ask them what's going on, right?
Uh-huh, right. No, they had to get creative. They took a deep dive into something called gradients.
Gradient?
Yeah. Think of them like signals that guide how an LLM learns, sort of like a feedback system that tells it how to adjust its knowledge during training.
Okay, so it's like a feedback loop.
Yeah, exactly. And the researchers, they analyzed these gradients across different layers of the LLM.
Okay, hold on. What are these layers you're talking about?
Good question. Imagine the LLM structure like a company, and it has different departments, each one specializing in a particular task.
Right, like different teams working on different things.
Yeah. And those departments, those are the layers, each one processing information in its own way.
So they're kind of like specialized processing units.
You got it.
Okay, that makes sense. So they're looking at these learning signals across different parts of the LLM's brain, so to speak, to see how it's all working together. What did they find out about this fast versus slow thinking idea?
Well, one of the really interesting things they found was that when LLMs were trained using step-by-step reasoning, that's like the slow thinking equivalent.
Right, like really breaking it down.
Yeah. Yep. They found that their learning became much more stable.
So it's not just about how fast an AI can learn something. It's about how well it can hold on to that knowledge.
Yeah. That's a key takeaway.
Makes sense. It's like if you cram for a test, you might pass. But you probably won't remember much afterwards. Did they find any other benefits to this slower, more methodical approach?
Absolutely. It turns out that slow thinking training also made LLMs much better at spotting errors in reasoning.
Like they learned to double check their work.
You could say that.
That's pretty impressive.
Hmm.
So how did they actually test this error detection ability?
So they did something clever. They fed the LLMs illogical arguments.
Like what kind of illogical arguments?
Basically nonsense statements, things that didn't make sense logically.
So like trying to trick them.
Exactly. And they wanted to see how the LLMs would react.
Okay, I'm curious.
Well, the ones that were trained on slow thinking, they showed really strong learning signals. It was like they were saying, hold on, this doesn't add up.
So they could actually recognize the flawed logic. Yes. But what about the LLMs that hadn't been trained to think slowly?
Ah, those are interesting to watch. They basically couldn't tell the difference between a sound argument and complete nonsense.
Oh, wow. So they just took everything at face value.
Pretty much. This really highlights how important it is to teach AI how to think, not just what to think.
Yeah, that's a crucial point. It's like teaching critical thinking skills along with all that other knowledge.
Exactly.
So slow thinking leads to better learning and better error detection. Was there anything surprising in the research? Anything that challenged those common assumptions we have about AI?
You know, there was one finding that really caught my eye. It turns out that those fine-tuned LLMs, the ones specialized for very specific tasks, they weren't always better at spotting those logical errors compared to their more general counterparts.
Really? I would have thought that the specialists would be the reasoning superstars.
You'd think so, right? But this research shows it's not always that simple.
Interesting. It's a good reminder that even with AI, things aren't always as straightforward as we might think.
Absolutely.
So we've learned that slow thinking is beneficial, and that just specializing in LLM doesn't guarantee it'll be a logic whiz. What other insights did this research reveal about how LLMs learn?
Well, they discovered something pretty interesting about the different layers of an LLM and how they learn.
Okay, remind me, what were those layers again?
Remember we talked about how an LLM is kind of like a company with different departments?
Right, each specializing in a different task.
Yep. Well, it seems like those different departments or layers that might have different learning styles.
Oh, that's interesting.
Yeah.
So tell me more about that.
Remember how slow thinking led to more stable learning signals,
Hmm.
especially for tasks that required a lot of logical reasoning?
Yeah, it was like having a solid thought process really helped them.
Exactly. But when they gave the LLMs a bunch of factual knowledge,
Hmm.
like imagine just feeding them tons of information from Wikipedia.
Okay, I can picture that.
They found that simply making the LLM generate longer responses, it didn't have the same effect as that structured, slow thinking approach.
So even though they were producing more output, they weren't necessarily understanding the information better.
It seems that way. It's like they were just spitting out facts without really grasping the meaning behind them.
Kind of like a student who can memorize a textbook, but can't actually apply the knowledge to solve problems.
That's a great analogy. It suggests that LLMs might have different learning mechanisms for different types of information.
That's fascinating. So you're saying that even within a single LLM, there could be different learning styles at play.
That's right. It's not a one-size-fits-all situation.
So this is all really cool, but why should our listeners care about all this?
Well, here's the thing. Understanding how WLMMs learn, it can lead to much more efficient training methods.
So we could train AI models faster and using fewer resources.
Exactly. It could really change how we develop AI tools.
That's exciting.
And you know those insights about fast versus slow thinking? Those could help us build AI systems that are much less likely to make logical errors.
Oh, that's really important.
Yeah. Imagine AI that can not only process information, but also critically evaluate it, recognize biases, and even explain its reasoning to us in a way we can understand.
That would be a huge step forward in building trust in AI. We could start using it in even more areas of our lives.
Exactly.
This has been a really eye-opening look at how LLMs learn.
It has been fascinating, hasn't it?
Yeah. Now, for our listeners who want to dig into the details, we'll be back after a short break to go over some of the specific data sets and findings from the research.
We'll unpack how those slow thinking patterns showed up in different reasoning tasks and what it all means for the future of AI.
Sounds good. Stay tuned.
Welcome back. Let's dig deeper into how these LLMs learn.
Yeah, I'm ready for more.
All right. So remember how we talked about fast and slow thinking?
Yeah, there's different ways of processing information.
Right. Well, the researchers really wanted to put that theory to the test. They didn't just look at one type of problem. They used a bunch of different data sets to see if those fast and slow thinking patterns showed up across different situations.
So like testing them in different subjects, like a comprehensive exam for AI.
Exactly. They used math problems, common sense reasoning tasks, even tasks that involved extracting knowledge from Wikipedia.
Okay, so a real variety of challenges.
Right. They wanted to make sure these patterns weren't just specific to one type of problem.
Makes sense. You got to test them thoroughly.
Yeah.
So tell me more about these math data sets. Were the LLMs solving for X or something?
Kind of. They covered a range of mathematical concepts, from basic algebra to geometry problems. One of the data sets they used was called AQUAWAY, short for Algebra Question Answering.
Word problems. Those can be tricky, even for humans.
Exactly. And here's where it gets interesting. They found a clear link between slow thinking training and how stable those learning signals were.
Yeah, so if the LLM was trained on step-by-step solutions,
Right, like really breaking down the reasoning process.
their learning was more solid.
Yeah, much more
It
consistent.
was like they actually understood the concepts, not just memorizing formulas.
Exactly. But when they only gave the LLMs the answers, without those reasoning steps, their learning signals were all over the place.
So they were just guessing.
Kind of, it highlights how important that step-by-step process is.
It's about understanding, not just getting the right answer.
I agree.
Did they see similar patterns in the common sense reasoning data sets?
They did. Common sense reasoning is all about those everyday situations.
Like if someone's carrying an umbrella, it's probably raining.
Yeah, exactly. Stuff we humans take for granted.
Right. How do you even test an AI for that?
Well, there are data sets specifically for common sense reasoning. One they used was called CREAK. It stands for Common Sense Reasoning over Entity Knowledge. It gives the LLM scenarios where it has to understand relationships between people, places, things.
So testing their ability to kind of connect the dots in a story.
Yes, exactly. And just like with the math problems, when LLMs were trained on those step-by-step reasoning paths, their learning signals showed a much deeper understanding.
It's like they could actually picture the situation and reason through it.
Yeah, it's pretty amazing.
But without that guidance, they were just memorizing facts.
It seems that way.
They might know what an umbrella is, but not necessarily understand why someone would be carrying one.
It's that deeper level of understanding that slow thinking seems to foster.
This is all so cool. But before we move on, I want to go back to something you mentioned earlier about those fine-tuned LLMs, the specialists. They weren't always better at spotting errors than the general models.
Right. That was a bit of a surprise.
Yeah, I would have thought they'd be the logic experts.
You'd think so. Yeah. But even with those very specific instructions, they weren't necessarily better at catching those inconsistencies.
So even though they were trained for a specific task,
Right.
they could still fall for those logical traps.
It seems that way.
It's like knowing the rules of a game, but not really understanding the strategy.
Yeah, that's a good way to put it.
It shows we need to do more than just give LLMs instructions. We need to figure out how to help them develop those critical reasoning skills.
I agree.
So we've seen how slow thinking helps with reasoning tasks. What else did the researchers find out about these learning signals?
Well, they also looked at how LLMs learn different types of knowledge. They compared how they learn popular knowledge versus unpopular knowledge.
Okay, well, what does that mean?
Think of popular knowledge as information that's really common, like the capital of France or the name of a famous historical figure.
Stuff everyone knows.
Yeah. And then unpopular knowledge is more niche, more obscure.
Got it.
And they found something interesting. When LLMs were trained on that unpopular knowledge, their learning signals were much larger and more erratic.
Like they were really struggling with it.
Yeah, it was as if they were encountering something completely new.
Did that suggest anything about how LLMs might prioritize information?
It's a good question. It raises the question of whether they might have a bias towards popular knowledge. Are they more likely to remember and use information that's more widely known?
It's interesting to think about. It's like they're more comfortable with mainstream information.
Right. And it makes you wonder if we need to be more careful about how we train them.
Yeah, we don't want them to be limited to just the popular stuff.
Exactly.
This has been a fascinating look at LLM learning.
It really has.
Now, let's shift gears and talk about what all this means for the future of AI.
Okay, sounds good.
We'll explore how these findings could lead to better training methods, more reliable systems.
And maybe even a deeper understanding of our own minds.
I can't wait to dive into that. Stay with us as we continue exploring the incredible world of LLMs. All right, so we've really dug deep into how LLMs learn.
Yeah, we've covered a lot of ground.
From fast and slow thinking to those different learning signals. It's been pretty mind-blowing, to be honest.
It has.
So now, the big question. What does all this mean for the future of AI?
Right. How can we actually use these insights?
Exactly. We've seen how training methods, the types of data, even how specialized an LLM is. It all affects how they learn to reason. So where do we go from here?
Well, one of the most exciting things I see is the potential to develop much more efficient training methods for LLMs. Imagine being able to train these powerful models in a fraction of the time and using way fewer resources.
Wow, that would be a huge breakthrough.
It would.
It's like we could unlock AI's full potential much faster.
Exactly. And by understanding those learning signals, how different parts of the LLM process information, we can really optimize that training process.
That's really cool.
And, remember how slow thinking training seemed to make LLMs better at spotting errors?
Yeah, like they were learning to fact check themselves.
Right. Imagine LLMs that can not only generate text, but also critically evaluate it.
They could point out biases, inconsistencies, even explain their reasoning in a way that we can understand.
Exactly.
That would make us a lot more confident in using AI. We could use them in even more sensitive areas, knowing they're less likely to make mistakes.
It's like having an AI partner you can really rely on.
So we've got these potential advancements in AI technology, but you mentioned something earlier about how these findings could even impact our understanding of ourselves.
Ah, yes. By studying how these artificial systems learn, it might actually give us clues about how our own minds work.
That's a fascinating thought. So AI could teach us about human intelligence.
Exactly.
That's pretty mind-blowing.
It is, isn't it?
Feels like we're at the beginning of something really big here.
We are. This is a whole new era of AI. And understanding how these systems learn, it's just as important as what they can do.
Well, this has been an incredible deep dive.
It has been a pleasure.
We've learned so much about how LLMs learn, and the implications are huge.
They are.
It's an exciting time to be following this field, and we can't wait to see what the future holds.
We hope you've enjoyed this exploration as much as we have.
If you want to learn more, check out the show notes for links to the research we talked about. And be sure to subscribe to The Deep Dive for more fascinating explorations of science and technology.
Until next time, keep those minds curious.
And keep diving deep.